Here are three problems from the final section in Chapter 1, which is solving absolute value equations and absolute value inequalities. So we're going to start with the one in the upper left corner, which is an equation. This directions would only say solve. There is no graphing that has to be done with an equation. First thing you want to do is you want to isolate the square root. You cannot distribute that 2. That is not a parenthesis. It's an absolute value bar. It cannot distribute. So first we're going to add 4 to both sides, giving you 2. Absolute value of 3x minus 1 equals 14. And then I want to divide both sides by 2. What you're doing is you are isolating what is in the absolute value bar. Now we can create a tree. A lot of times I'll have a tree going this way and this way. I'm going to actually just go this way and this way. One option is that it's exactly what you see without the absolute value bar. Nothing's changed. So 3x minus 1 equals 7. The other option is that 3x minus 1 equals negative 7, because that absolute value might have gotten rid of a negative value. We have 2 to solve. We'll get 2 different answers even though the steps will be the same. So up top we're going to add 1. We get 3x equals 8. Divide by 3. One answer is that x equals 8/3. That is a fraction that cannot be reduced, so we're going to leave it. Going the other branch, we're going to add 1. We get 3x equals negative 6. Divide by 3. We get x equals negative 2. If you want to check and see if you are correct, you can take both of those values for x, plug it into the original equation up top, and make sure you get both sides to equal 10. The second problem is an absolute value inequality, and you want to think about whether it's a less than or a greater than, because that tells you the type of compound inequality you want to write. Because this is a less than, we talked in class, you should think less than means and. Less than and, they kind of rhyme. So we're going to create an and statement. Before we do that, we have to isolate the absolute value. So first thing I'm going to do is multiply both sides by 2. So I get the absolute value of 6x minus 4 is less than or equal to 4. Now we are going to write as an and statement because it started as a less than. And statement has the double inequality. They will both look identical to what the original says. If the original has an or equal to, both of them will have or equal to. You put the 6x minus 4, this piece in the middle. This side gives you the 4. The other side you put the opposite of that number. So you'll have a 4 on the right and a negative 4 on the left. To solve this, you solve this the way we did in 1.6. We're going to add 4 to all parts of the inequality. We get 0 is less than or equal to 6x is less than or equal to 8. Divide everything by 6. 0 is less than or equal to x is less than or equal to 8. 6 can reduce to 4/3. When you're doing these problems, best thing to check, make sure inequalities in an and statement are both pointing the same direction, and make sure they're both pointing to the smaller number. When you go to graph these, because these problems tend to have the direction solve and sketch a graph, put both numbers, they will both be closed circles. In a absolute value inequality, the circles will either both be closed or both be open, and then we are connecting in between. What that means is if you picked any number between 0 and 4/3, like 1, and put it up into the original equation, you would get a true statement. The last problem is also a compound, creates a compound inequality. You start with an absolute value. You need to isolate the absolute value. So first step is to subtract 5. So 3 times the absolute value of x minus 1 is greater than 6. Divide by 3. We're isolating the absolute value before we start working with our inequalities. Now we want to think greater or. I know it's not really greater, but it's a great way to remember it. If you see a greater than sign with an absolute value, you create an or statement. One of your statements will be exactly what you started with, just drop the absolute value bars. The other statement that goes after the or is the same expression that was in absolute value bars, but it's going to be less than the opposite of this number right here. So instead of greater than 2, it's going to be less than negative 2. Add 1 to both sides, you get x greater than 3. Or add 1 over here, you get x less than negative 1. When you're graphing your or statement, we're going to put negative 1 first because it is the smaller number, and 3 over here. We are looking at numbers that are bigger than 3, so we have an open circle headed to the right with the arrow, and less than negative 1, we have an open circle heading left. Again, when it started out as an absolute value inequality, your circles will be the same, both open or both closed. So in this case, they both are open because they do not have or equal to. This gives you an example of one of every type of problem we did in 1.7.